So the first thing that you want to do after you assemble your circuit is to make sure that there aren't any air bubbles along the tubes. This is really important to make sure that we get accurate measurements for our flow rates. So as soon as you've made your circuit, you can just take each part of the pipe and raise it slowly, and this will get rid of all of the air bubbles, and you'll see them just float along until they come out through the other end. So in this activity, we're going to simulate the potential drop across resistors. So in this setup, you can see that between my inlet and my outlet, I have two resistors in series, and then before and after each one, I have a T-connector connected to a long pipe. So these pipes are going to act like our voltmeters, and the height that the water rises will be synonymous to the voltage. So in our analogy of electricity and water, voltage is being played by the role of pressure. So when we have an electric circuit, our power source, say a battery, is creating a potential difference, and that potential difference is stored as potential energy. Then within your circuit, you're able to expend that energy to power whatever's connected to the circuit. In this case, we have a motor pushing water, and that pressure provides the energy to raise the water level to a certain height. However, after each of these pipes, we have a resistor, and that's going to take away some of that energy. And so we would expect that after each resistor, the height level of the water will drop, and we can actually measure this. So now with my motor turned on and all of the air bubbles cleared out of my pipes, I can see that there is a height difference between each of the pipes. So what you want your students to measure is the height difference between the water levels in the first pipe and then the second pipe. So that's the pressure drop across the first resistor. And then you want them to measure the difference between the second pipe and the third pipe, and that's the pressure drop across the second resistor. Another thing that we can observe is that the pressure drop across the first resistor is significantly larger than the pressure drop across the second resistor. And that's because the first one is significantly longer than the second one. So from this, your students should be able to infer that the longer the resistor is, the more the pressure will drop across it. And this is the same case as in electricity. The longer your wire is, the more the voltage will drop across it, because that longer wire provides more resistance to the flow of current. So in this activity, we're going to measure the flow rate before and after each resistor. So in this setup, I just have the flow meter before the first resistor, but you want your students to measure the current after each successive resistor as well. So they're going to have to get creative and repositioning the flow meter such that it's connected between everything. But we have multiple connectors and pipes, so they should be able to do it just fine. So what you're actually measuring is how long it takes the black pedal to go around in a complete circle 10 times. So you're going to have to use a timer, and just one of the students, preferably the same student watching the pedal, should also be using the timer so that it's more synced. Going back to our analogy with electricity, flow rate here is synonymous with current, and what your students should find is that no matter where they position the flow meter, the flow rate is always the same. So that's similar to in a circuit. Whenever you have things in series, the amount of current in is the same as the amount of current coming out.